Okay, now we have to solve the second question under the exponential equations, alright? Okay, we have here that 4 is being multiplied with 4 to the power x minus 2 to the power of x. We add 1 to that, that is going to give us 2 to the power of x. So we have to find the value of x that satisfies this equation, okay? Either the value of x or values of x. So depending whether we will have more than 1. So which particular real number can we have such that this will be satisfied? So that is called the x. Okay. Now, let's just go ahead and solve this without lots of considerations. So I'm going to multiply this throughout in the bracket. I'm going to have 4 times 4 to the power of x minus 4 times 2 to the power of x plus 1 equals to 2 to the power of x. Alright? So just multiplying this with that, and we add 1 and we equate it to the right hand side. Okay, great. Well, again, here I would like to collect like terms, alright? So this, which is on the right hand side, 2 to the power of x, it has the same thing here, alright? Just that this one is 4 of them. So if I move this to the left hand side, I'm going to have 4 times 4 to the power of x, right? And I'm subtracted with 4 times 2 to the power of x, alright? And then minus this one, minus 2 to the power of x. This is x, alright? We add 1 to that. So this is the one that is here. This was here already, and this was here. So this is the remaining one. And on the right hand side, we now have 0. Okay, what we've just done is to subtract 2 to the power of x from both sides. Alright? Okay, great. So let's just move over to this. But take note that this 4 to the power of x, it is the same thing as 2 to the power of x all squared. Alright? Okay, maybe I will put it down one after the other. Now, this one, I'm going to write it as 4 times, in place of this 4, I'm going to write 2 to the power 2. Alright? And remember, that was raised to power x. So this is 2 to the power of 2. 4 alone is 2 to the power 2. And 2 to the power 2 is raised to power x, finally. Alright? And since multiplication is commutative, that means I can write 2 times x, or I can write x times 2. Okay, so I would like to write x times 2 because I want to get a pattern. Just like we did in the first question, number 1. We changed this to the first question to a quadratic form, right? So that is something I would like to do to the second question. Okay, so we see that this is minus 4 times this minus this. Now, when you have negative, let's say negative 3x, right, minus x. What we enter with is negative 3 minus x is negative 4x as an answer, alright? And again, if we have negative 4y minus y, all we will have is negative 5y. So why I'm using that is, this negative 4 is here, this is negative of 2 to the power x. So assuming this 2 to the power of x is y, alright? So what we will have is negative 4 of that y minus that y itself, that is negative 5y. So here I'm going to write negative 5 times 2 to the power of x. So assume this 2 to the power of x to be y, alright? Just like this one. And you are going to get just that, negative 5y, alright? Okay, so that is negative 5 times 2 to the power of x. So just, okay, so we add 1 to that. We equate that to 0 on the right hand side. So we just need to go ahead and look at this, okay, finally in a quadratic form. So what I will do here is to make a replacement, just like we did in the first question. I say, okay, let's make a replacement here. Let t be equal to 2 to the power of x, alright? So that means in the main equation we are going to have 4 times t. Okay, so in place of 2 to the power of x, I'm going to put down t, and I'm going to square that minus 5 times, in place of 2 to the power of x, we just put down t, alright? Okay, we go ahead and add 1 to that, and we equate it to 0. We are now ready to solve this as a quadratic equation. So either we use the quadratic formula or we use factorization method. Let's see if factorization method is going to work out here. Well, yeah. We're actually going to use factorization method. I love that method. So, I know it's actually a little bit stressful for students, but it's actually very wonderful. So what we'd like to do here is to look at the coefficient of t to power 2, alright? The coefficient there is 4. Look at this constant term. Here it was 15, here it is just 1. What we need to do is to multiply this coefficient of t squared with the constant term. So 4 times 1 is 4. Now, seek two numbers. When you multiply them, you have that result. That is, 4 times 1 is 4. Alright, this is 4, this is 1. So you seek two numbers, two other numbers, either same numbers or different numbers. When you multiply them, you are going to have the 4, that is the product of this and this. When you add them together, you are going to have this negative 5, that is the coefficient of this t. Alright, so since we've had 4 here, which numbers can I add together to have negative 5? Okay, so the numbers are, which numbers am I going to multiply together to have this 4, that is the product of this and this, and such that those numbers, when I add them together, I'm going to have negative 5, alright? So what we need to look at is this and this. So to multiply numbers together to have 4, those numbers can be 2 and 2, they can be negative 2 and negative 2, they can be negative 4 and negative 1, they can be 4 and 1. Alright? Now, sum each of these together. Which of them will give you negative 5 when you sum? This first one will give us positive 4. Okay, so we clean it off. This second will give us negative 4 when we sum them. We clean it off. This fourth one will give us positive 5 when we sum them up. But it is only this last one that will give us negative 5 when we sum them up. So these are the two factors which when we multiply to give us positive 4, when we add them to give us negative 5. Remember, this positive 4 is gotten from the product of this and this, alright? Okay, it is not only this one, the product of this and this, in case this is bigger than 1. So the two numbers, they are negative 1 and negative 4. So this is how we would like to rewrite this. We would like to write it as 4t squared, alright? And in place of this negative 5t, we will replace it with negative 4t, and we replace it with negative t. Remember, there were negative 4 and negative 1. So we will just multiply t to each of them. Negative 4t and negative t. And we add 1 to that, we equate this to 0. Okay. Here we need to start with the factorization. We take things that are common here. This is 4t, and we'll have it to be t plus 1. That is, I just took out, this is t minus 1. Here, just take out what is common, that is 4t, right? Here is t squared. We don't have to take 4t squared because this one is not up to that. So 4t, t will remain here, and here will be remaining with 1. Okay, the next thing I'd like to factorize here is negative 1, alright? Okay, since this one has the negative, first term there has a negative, I would just like to take that one out. And what we will be left with is t minus 1. Okay, such that when we multiply it throughout in the bracket, we get back negative t and positive 1. Okay, so looking at this, t minus 1 is here, t minus 1 is here. We can factorize that bracket. We will have 4t minus 1. Then we factorize the bracket, t minus 1 equals to 0. Okay, so here we see that product of two terms is giving us 0. At least one of them is 0, as always. So we equate 4t minus 1 to 0, and we also equate t minus 1 to 0. So it is an OR statement. That OR they mean either this one or this one. It can also mean both of them, but there's no point writing it again. Okay, so this is 4t is 1, and then t is 1 over 4. Alright, so we'll move on to the right hand side, divide both sides by 4. Here, that means t is 1. Okay. You recall that we made a statement earlier, let t be 2 to the power of x. So we make a backward substitution. Now, just like we did, okay, so maybe it will be very necessary to go back to watch the first video because these are just the steps that I used to answer the question 1. Question 1 is quite interesting as well. Okay, so t is 1 over 4 or t is equal to 1. So what we would like to do is make a backward substitution because our aim here is to solve for the value of x, not the value of t. We only brought that in, alright? Okay, so to actually get that, we will need to in place of t here, we will need to put 2 to the power of x. So if t is equals to 1 over 4, that means that 2 to the power of x is 1 over 4, right? Okay, now this 1 over 4 is the same thing as 2 to the negative 2 power, 2 to the negative second power. So this is it, 2 to the power of negative 2, right? Okay, if you know that already. So here, all we need to do is to just cancel the powers, and we will see that x is negative 2, all right? That is the first value of x. Now here, when t is 1, well, all we need to do is to substitute 1 in place of t. That means that 2 to the power of x is 1. In fact, 1 can be written, I want to rewrite it such that they have the same basis, so that I will just cancel them, just like we did here. Okay, so I would like to rewrite this as 2 to power 0. You know, when you're raising a number to power 0, you get 1. So here, 2 and 2 will cancel, and that means that x is 0. So the two values of x are negative 2, and 0. Alright? Okay. Alright, that was very nice, alright? Let's move on to the number 3 question.